A nice diff is not enough. Propose a patch, run one check, and summarize the risk. If your code review workflow feels slow or nerve-wracking, this video shows a small, repeatable pattern you can use right away to reduce surprises. You will learn how to fetch a minimal context from a repository, generate a clear diff, run one cheap safety check, and then summarize risk so you can decide with confidence. This keeps feedback fast and makes human review more focused. I'm Professor Pi, teaching AI engineering and LLM systems from basics to advanced with simple, concepts-first Python that helps you solve bigger, real-world problems. Many teams get stuck when an automated assistant suggests code changes without enough context or checks. You want the assistant to act like a cautious teammate. Fetch the most relevant files, propose the smallest sensible change, run a quick verification, and give a single risk signal so reviewers know what to focus on. Success looks like fewer surprises in production and faster reviews for small, safe patches. At its heart, this workflow is simple and practical. We retrieve a trimmed view of the repo so the assistant has a focused context. We diff the candidate change to measure size. We run one targeted test that catches the most likely regressions. Then we combine those signals into a single risk score to guide decision-making. We will build a tiny demo that uses a micro repo with 2 files, proposes a minimal change in one utility, runs a quick behavior test, and reports a risk number. The goal is not to replace full CI. The goal is to triage and accelerate low-risk patches. Now, we will retrieve the most relevant files from the repo and build a small context window. This snippet selects the most relevant repo files for a given query. The dictionary repo stands in for our codebase with 2 small modules. The function score counts how many query words appear in each file's content to provide a tiny lexical signal. We split the query into words with set and sort file names by descending score to keep ordering deterministic. We then build CTX, a trimmed view of the repo that contains only the top 2 files. The printed list shows which files were retrieved, providing a minimal, fast context window for downstream steps. After you see which files are returned, the assistant can focus only on that context instead of scanning unrelated code, which keeps latency and noise low. Next, we will propose a concrete code change and compute a readable diff summary. This snippet proposes a code change and computes a readable diff with difflib.ndiff. We take the original util Pi code as old and create canned by swapping the ternary to make the zero check explicit. The function difflib.ndiff generates a side-by-side style delta list where lines prefixed with plus and minus represent additions and deletions. We count those change markers to get a tiny change magnitude signal saved in change. The printed number shows how much code is changing, which will later inform our risk summary. In practical terms, a small change means the proposal is minimal and easier to review. A large change would flag that the patch touches many lines and deserves a deeper look. Now, we run a single, lightweight behavioral check to validate the patch idea. This snippet runs a single, lightweight check to decide whether to apply the patch. We exec the candidate code string into the namespace ns so we can call safediv dynamically. The helper one check quickly verifies 2 critical behaviors. Divide by 0 returns 0, and normal division is correct. The Boolean OK gates the change, and decision becomes apply or skip accordingly. The printed decision communicates if the proposal is safe enough to move forward without a heavier test run. This one check is chosen to match the change intent. Choosing a different check would shift what safe means. So pick a check that exercises the change's core behavior. If the single check passes, we apply the patch and run a tiny test slice to confirm nothing obvious broke. This snippet applies the patch and runs a tiny quiet test slice to confirm behavior. If the decision was applied, we replace the file in repo, then exec it into NS to get the updated safe diff. The list tests defines 3 quick cases, but limit constrains how many we execute to keep latency predictable. The variable passed counts correct outcomes across the selected slice, mimicking a minimal pytest-style pass tally. Increasing limit improves confidence at the cost of time. Decreasing it reduces latency, but may miss issues. The printed number clarifies how much of the suite we actually ran, which helps balance speed against assurance. Finally, we compress change size and test success into a single, easy-to-read risk signal. This snippet synthesizes diff size, test coverage, and impact into a simple risk score. We treat affected as a small penalty for touching a file, and compute coverage from passed over limit to reward test success. The change magnitude change scales into risk via a lightweight weight, so bigger diffs push risk up. We then clamp the result into 0-1 to keep the metric bounded and comparable across runs. The printed risk communicates whether the patch seems safe to merge or needs deeper review. In practice, you can tune the weight and the test slice limit to match your team's appetite for risk versus speed. To map this toy flow to a real project, replace the 2-file repo with a small subset of modules selected by a path or feature tag. Use a slightly larger test slice drawn from unit tests that exercise the changed functions. Swap the simple lexical score for a vector retrieval if you need semantic relevance at scale. Recap. This is a fast, repo-aware, safer workflow that retrieves focused context, diffs a candidate change, runs one critical check, and summarizes risk. Use it for small patches where full CI is expensive or slow, and you need quick triage. Caveat: it is not a substitute for full test suites or formal review on large or risky changes. Next step: tune the test slice limit and the diff weight so the risk score matches how conservative your team wants to be. If short, practical AI engineering helps, subscribe and watch the AI engineering videos.